The James Webb Space Telescope has given us a shocking revelation. The universe may have stopped expanding. This revelation has thrown the entire field of cosmology into turmoil. For nearly a century, we've built our understanding of the cosmos on the assumption that the universe has been expanding since the Big Bang. But now, this foundational belief is being questioned. Could we be standing on the brink of a cosmic catastrophe, like the Big Rip, where the universe tears itself apart, or the Big Freeze, where all energy dissipates into nothingness? Scientists are scrambling to make sense of these findings, and the space industry is at a turning point, one that could redefine the way we view space and time itself. To fully understand why this discovery is so monumental, we need to look back almost 100 years to the 1920s. This was a time when our understanding of the universe was far smaller, literally. We believed that our Milky Way was the entire universe. The concept of galaxies as separate entities was brand new. Astronomers were just beginning to realize that the universe was much larger than anyone could have imagined. One of those astronomers was Edwin Hubble. He was one of the first to observe these newly discovered galaxies, Andromeda, for example, and realized that our universe wasn't just one galaxy, but a vast collection of them. But Hubble's discoveries didn't stop there. He noticed something even more surprising. The galaxies farthest from us weren't just sitting still, they were moving away from us. And the farther away they were, the faster they seemed to be moving. This was a groundbreaking observation that led to the development of what we now know as the Hubble constant, the rate at which the universe is expanding. In 1929, Hubble published his revolutionary findings, but he wasn't the only one piecing together the puzzle of the universe. Around the same time, a Belgian priest and physicist, Georges Lemaitre, had also been studying the idea that the universe was expanding. Lemaitre suggested that the universe originated from a state of high density and temperature, a concept that later evolved into the Big Bang theory. His work, combined with Hubble's observations and the field equations from Albert Einstein's general theory of relativity, became the foundation of modern cosmology. And that foundation held firm for nearly a century. The idea that the universe is expanding has been a central pillar of our understanding of space and time, until now. With the launch of the James Webb Space Telescope, we're seeing a series of phenomena that challenge everything we thought we knew. The telescope's powerful instruments are showing us images and measurements that are no longer compatible with our current theories. The cosmos, as we've understood it for decades, may not be expanding after all, or at least not in the way we believed. This crisis isn't entirely new. For years, physicists have noticed discrepancies between their calculations and the behavior of the universe. One of the biggest puzzles has been the existence of dark matter and dark energy, two mysterious forces that seem to govern much of the universe's behavior, yet remain completely invisible and unobservable. We only infer their presence because of the gravitational effects we see in galaxies and the cosmic microwave background radiation. But what if we've been interpreting those effects all wrong? What if dark matter and dark energy don't exist at all? The possibility that our entire cosmological model is flawed is a daunting one, but it's not outside the realm of possibility. And if the universe isn't expanding in the way we think, then many of our other theories, like the existence of dark matter, might not hold up either. It's possible that we've misjudged the dynamics of the cosmos, and with Webb's discoveries, we're starting to see the cracks in our understanding. For example, researchers discovered in the late 1990s that the expansion of the universe wasn't just continuing, it was accelerating. This led to the hypothesis of dark energy, a force that supposedly pushes the universe apart at an ever-increasing rate. But what if that acceleration was an illusion or the result of flawed measurements? Some scientists are now asking if there's even a space for the universe to expand into, or whether our understanding of cosmic expansion itself is fundamentally wrong. Imagine for a moment that the universe isn't expanding in a linear fashion at all. Instead, some scientists propose that it might behave more like a giant whirlpool, with energy and matter being channeled into different regions of space from multiple sources. In some areas, the cosmic flow might be turbulent, while in others, it's calm, much like the jets and eddies in a whirlpool. If this is true, then the idea of an ever-expanding universe would disappear entirely. The concept of dark energy might become unnecessary, replaced by a more complex dynamic model of the cosmos. And this isn't the only alternative theory being discussed. Some cosmologists are turning to other models that don't require dark matter or dark energy. One of these is the tired light theory, first proposed by the Swiss astrophysicist Fritz Zwicky in the 1920s. According to this theory, the redshift we see in distant galaxies, the key evidence for the expansion of the universe, might not be caused by galaxies moving away from us. Instead, light itself might lose energy as it travels across vast distances, which would make it appear redshifted without requiring the universe to expand. There are other, even more radical theories as well. One suggests that the speed of light might not be constant throughout the history of the universe. If light traveled at different speeds in the past, then our entire understanding of cosmic distances and the expansion rate could be skewed. Another theory, called MOND, modified Newtonian dynamics, proposes that the force of gravity itself isn't constant but changes over time. Perhaps the most fascinating idea comes from the field of quantum mechanics, the theory of holographic gravity. This theory, developed by physicist Eric Verlun, suggests that gravity isn't a fundamental force of nature at all. Instead, it might emerge from the underlying principles of quantum information and thermodynamics. In other words, the universe might function like a giant hologram, with gravity being a byproduct of deeper, unseen processes. If this is true, then our entire reality could be far more complex than we ever imagined, and we might even play a role in creating the physical phenomena we observe. So where does this leave us? The discoveries made by the James Webb Space Telescope are forcing us to confront the possibility that we've been wrong about the universe in some very fundamental ways. And while it's terrifying to think that our understanding of the cosmos might be built on shaky foundations, it's also incredibly exciting. We could be on the verge of a new era in physics, one where the concepts of dark matter, dark energy, and even the expansion of the universe itself are replaced by entirely new ideas. But these revelations also lead us to some unsettling questions. If the universe isn't expanding, what comes next? Are we headed for the Big Rip, where the universe is torn apart as its energy dissipates? Or could we be approaching the Big Crunch, where the universe stops expanding and collapses in on itself? And what about the Big Freeze, where all energy is eventually used up, leaving the universe in a state of frozen, eternal stillness? The idea that the universe could suddenly stop expanding and that we could be living in a cosmic whirlpool or a hologram may sound far-fetched, but it's a real possibility that scientists are now considering. The implications for our understanding of space and time are staggering. We may soon need to rewrite the very laws of physics as we know them. The universe, as the James Webb Space Telescope is showing us, is far more dynamic and changeable than we ever thought. And while that's a humbling realization, it also opens the door to a whole new realm of possibilities. Could we be living in a multiverse, with bubble universes constantly forming, each with its own unique physical properties? Is the idea of eternal inflation, where certain regions of the universe continue to grow exponentially while others stop, more than just a theory? The discoveries we're making right now are shaking the foundations of modern cosmology. We've constructed a house of cards, and the latest data is causing it to wobble. Theories that have stood for nearly a century, like the expansion of the universe, dark matter, and dark energy, are now being questioned. And as we move forward, we may find that many of these ideas were based on observational errors or flawed assumptions. We are witnessing a pivotal moment in the history of science. The universe hasn't just come to a standstill. It's our understanding of it that has. And as we continue to gather data from the James Webb Space Telescope, we'll be forced to confront even more challenging questions about the true nature of reality. The future of cosmology is uncertain, but one thing is clear. We are on the verge of a scientific revolution, one that could change everything we thought we knew about the universe.